Okay, so good morning class or good afternoon. Depende kung anong oras matapat ang inyong CC1 laboratory, no? Okay, so with this week's laboratory activity for CC1, we're going to deal with your spectrophotometry. So this is in line with Ma'am TJ's lecture with you. Entitled Analytical Techniques and Instrumentation. Okay, so let's start by discussing what are the different learning objectives of this activity. So first, or at the end of this activity, the students shall first discuss the concepts and principles of instrumentation and automation. So these different analytical methods and instrumentation was thoroughly discussed with you by Ma'am Hawla during her lecture. Okay, that's why the main focus of my short discussion or a simple orientation for you will only focus on your spectrophotometer, okay, or the spectrophotometry. Next learning objective is for you to identify the different spectrophotometer components. So then again, this was part of your lecture. However, gusto ko lang ulit i-discuss and sabihin ulit sa inyo para ma-refresh, okay, yung mind nyo on this different component of the spectro. Okay, and then lastly is to demonstrate the proper use of spectrophotometer. So the video uploaded on our Moodle course shows you on how to properly use our spectro or the spectrophotometer available here in our laboratory. Okay, so hopefully by next SEM, hindi na lang puro video or whatsoever ang makikita nyo, but rather kayo na mismo, okay, yung mag-ooperate ng ating spectrophotometer. So, hopefully, maging okay na ang lahat para naman ma-feel nyo talaga kung ano ba talagang ginagawa ng isang medtech in the laboratory. Okay? So, supposedly, if we are in the laboratory here at school, this will be my instruction for you. So, a typical spectrophotometer will be shown to you by your instructor, okay? And the parts and the techniques, okay, of operating will also be demonstrated. So, of course, for you to know kung paano ba ginagamit to, ano bang ilalagay dito, anong bang dapat iset dito, so on and so forth. Okay, so that will be the focus of my short discussion or orientation with you. Pero, yun din naman yung pinakita sa inyo with the video. So, para lang maulit-ulit, para ma-master nyo and at the same time, maintindihan ninyo. Okay? So, we're going to discuss that again. Okay? With this simple or the short discussion. Okay? So let's start with the different analytical methods that we can have or we can use in our laboratory. So, but before that, please allow me to turn off my cam kasi baka humina yung internet. Wala namang magsasabi sa akin na, Ma'am, choppy ka, Ma'am, di ka namin maintindihan. Okay? So, para continuous tayo and walang maging problema, okay, with the audio, let me turn off my cam. Okay? Ayan. So, sige. Again, let's start on discussing the different analytical methods that we can use in the lab. But then again, we're going to focus on spectrophotometry. But as the analytical methods is concerned, these are the different analytical methods we have in the lab. Okay, so first is your colorimetry. Your colorimetry, okay, we could either have a spectrophotometric analysis or measurement or spectrophotometry and photometric analysis or measurement or photometry. So between these two, or what is the difference between these two types of colorimetry method in the lab? So when you say spectrophotometry, okay, this is defined as the measurement of light intensity in a narrower wavelength. Whereas for photometric, this is a measurement of light intensity okay, without consideration of wavelength. So take note that when we deal with spectrophotometry, we are dealing also with wavelength. Okay? Another analytical method is your volumetric, turbidimetry, nephelometry. We have also electroanalytical methods or electroanalytic methods, and that could be done or be performed either by doing electrophoresis, potentiometry, and amperometry. We also have chromatography available in the lab, and that could be classified either as to planar or column. So dyan papasok yung thin layer chromatography, liquid chromatography, solid, liquid gas chromatography, etc. Okay? And lastly, we have your luminescence that could either be or could be performed by means of fluorometry and chemiluminescence. Okay? So for colorimetry, it's either we perform that using spectrophotometry, emission flame photometry, and another method is the atomic absorption spectrophotometry. So all those analytical methods that I mentioned was thoroughly discussed and discussed to you in detail, okay, during your lecture. That's why I will only focus with the spectrophotometry. Okay? So ulit-ulit, ang focus lang nito is the spectro. Okay? So in dealing with spectrophotometry, it's very important that we know this so-called EMR. EMR stands for electromagnetic radiation, and this is defined as the photons or packets of energy that travel in waves. Okay? And what are the terms used to describe your EMR? We have four. We have your amplitude, the energy, wavelength, and frequency. Wavelength is defined as the distance between two peaks. Okay? And wavelength could range from 400 to 700, and we consider that as belonging to the visible region or the visible spectrum. We have less than 400, and that is under the UV region. And if that is more than 700, or the wavelength we use is more than 700, that belongs to the infrared region or the IR region. Okay, so kindly take note that the UV region produces high energy, however, short wavelength, whereas the IR region produces short energy, however, longer wavelength. Okay, so UV region and IR region as general, they are known as the invisible spectrum or the invisible light. Okay, next term is your frequency, and frequency is defined as the number of vibrations of wave motion per second. Okay, and take note that the lower the frequency, okay, the longer the wavelength. So they have an inversely proportional relationship, okay, the wavelength and the frequency. So with that relationship, we could say that the wavelength is inversely related to frequency and, of course, your energy. So the shorter the wavelength, the higher the frequency and energy, and vice versa, meaning the longer the wavelength, okay, the lower the frequency and, of course, the energy. That's why we have this so-called Planck's formula. And this Planck's formula states that energy, okay, is equals to hv, where h is your constant, okay, whereas v is your frequency. So by following that formula, or kung titignan nyo yung formula na yan, we could say that the higher the energy, the higher the frequency, however, the shorter the wavelength. Kasi nga the wavelength and the frequency has inversely proportional relationship. Okay? And the lower the energy, the lower the frequency, however, the longer the wavelength. Okay? So pag mataas ang energy mo, mataas din ang frequency. So energy and frequency has direct proportional or direct proportional relationship. Okay? So spectrophotometry, kasi nga it's very important that this spectro uses that EMR. So spectrophotometry is one of the most useful method of quantitative analysis, and this is the most commonly used method for measurement of analytes in the laboratory. So there are many fields, in science that uses this analytical method. Okay, so it involves measurement of light transmitted, by a solution to determine the concentration of the light absorbing substance in the solution. So kindly take note of that. So in short, spectrophotometry is a measurement of how much a chemical substance absorbs or transmit light. Okay? Again, in short, spectrophotometry deals with measurement of how much a chemical substance absorbs or transmit light. By the way, class, I forgot to mention, if you have any questions, as we go on through the discussion, kindly take note of that question. You can ask me, that question by next week when we have our Zoom meeting. Okay? So, take down or i-take note nyo lang muna yung mga questions ninyo. I'm willing to answer that para mas malinawan kayo kasi wala namang masamang magtanong. Okay? Mas maganda yung naiintindihan nyo. Okay? So going back again, spectrophotometry involves the measurement of how much a chemical substance absorb or transmit light. And of course, your spectrophotometry uses this instrument called as your spectrophotometer. So spectrophotometer is an instrument that measures the amount of photons or intensity of light absorbed after it passes through the sample solution. Okay, so that is the purpose of your spectrophotometer. And using your spectrophotometer, the amount of a known chemical substance or the concentration, of that substance can also be determined by measuring the intensity of light detected. So that is then again another purpose of the spectrophotometer. So your spectrophotometer is consist of two devices. We have the spectrometer and the photometer. So the spectrometer is the device that typically dispense and measure the light. Okay? So the spectrophotometer or the spectrometer produces the side range of wavelength of light, and then the collimator transmit or the entrance slit transmit a straight beam of light or the so-called photons that passes through a monochromator to split it into several component wavelengths. Then a wavelength selector or an exit slit transmit only the desired wavelength. So in short, you have an idea on what are the component of your spectrum photometer. That's why from the light source up to the monochromator, that is part of this spectrometer. Okay, again, the spectrophotometer is the device that typically dispense and measure the light. So having an idea on the component of the spectrophotometer, we can say that from the light source, the entrance slit, the monochromator, the exit slit, that is part of the spectrometer. Whereas the photometer, so this is the device, present with the spectrophotometer that indicates the photoelectric dictator that measures the light. So from the photodetector up to the readout device, that is actually your photometer. So a combination of the light source up to the readout device, those are the component, or that consists your spectrometer. The spectrophotometer, not the spectrometer, but rather the whole spectrophotometer. So these are the different types or kinds of spectrophotometer that you can encounter in the laboratory. Okay? Ayan. So they have there the sample compartment. The source, monochromator, and detector is actually inside. Hindi nyo siya makikita. Okay? Physically or outside the spectrophotometer. And you have also the display and controls. And this one. Okay? So the last picture, okay, na nakita nyo is actually the spectrophotometer we have in our lab. So, nung student ako, iyan yung ginagamit namin. However, ngayon, sira na siya. Okay? Kaya we cannot let you use that anymore. Kaya we have that new one. The one shown to you doon sa ating video. Okay? So, not limited to these three, no? Madami pang ibang type ng spectro ang pwede nyong ma-encounter. Basta you should know of the different component of the spectro. Okay? Para alam nyo din on how this equipment works. Okay? So, with that, what are the basic parts of the spectrophotometer? Again, we have the light source, the entrance slit, the monochromator, the exit slit, the cuvette, or that is the two, okay, spelling of our cuvette, photodetector, meter or readout device, and sometimes recorder is also considered as part of your spectrophotometer. Entrance slit, baka yung iba mabasa nyo, sometimes ang tawag nila dito is a collimator, whereas the exit slit is known as the wavelength selector. Okay? So let's discuss one by one. Pero simple discussion lang naman, hindi tayo sobrang detailed, okay, na tulad ng sa lecture. Before we discuss each of the component of your spectro, so these are the components of your spectro in one picture. Okay, so you have here, okay, the light source. Ayan siya. Okay, the light source, you have the collimator or the lens. However, sometimes nga tinatawag natin siyang entrance slit. You have your monochromator. Okay, so we have other available monochromator, depende kung anong gusto nyong gamitin. You have the wavelength selector or also known as the exit slit. You have the sample solution that is in the cuvette, the photo detector, and the digital display or the readout device. Okay, so it's either of those. So another picture that will show you the basic component of your spectro is this one. So again, you have the light source, the entrance slit, the dispersing device or the monochromator, the exit slit, the cuvette that holds the sample, and of course your photo detector. And additional to that is the digital display or the readout device. Okay? So let's start with the light source. So light source is also known as the excitation source or the excitation lamp. So this component of your spectro provides your EMR or the electromagnetic radiation. So your light source can be continuum, okay, or line. When you say continuum, it emits radiation that changes in intensity. Whereas for the line light source, it emits only limited radiation in wavelength. Okay? So light source also is considered as the most important part of our spectrophotometer. So kung may pagkakaingatan ka with all of those, ang pinakauna mong iingatan is the light source. Okay? Light, okay, or the source of your light or this light source could produce this different wavelength. Okay, so it's either producing visible light, UV light, or infrared wavelength. Okay, so visible light or the visible region is provided when you make use of a tungsten iodide lamp or halogen lamp as your light source. UV region, okay, is provided when you make use of a hydrogen lamp, deuterium lamp, mercury lamp and a xenon lamp, whereas the infrared region could be produced when you make use when you make use of the silicon carbide rod heated at 1200 degrees Celsius as your light source. So depende sa wavelength na gusto mong gamitin, okay, yung magiging light source mo. Kasi iba-ibang light source, iba-ibang type ng light source can produce a different range of wavelength. Okay, so kindly take note of this different light source that can be used depending on the wavelength needed for the measurement or for the spectrophotometer. So next is the entrance slit. So this entrance slit has the purpose of minimizing unwanted or stray light. Okay, when you say stray light, this is defined as the wavelengths outside the band transmitted by the monochromator. So straight light is kind of like, or in short, this is the unwanted, okay, or the undesired light. Okay, pag sinabi mong unwanted or undesired, it should not hit the monochromator. Okay, so this entrance slit prevents the entrance of scattered light to the monochromator. So for some nga, they call this as your collimator lens. Okay? So next component or next part of the spectro is your monochromator. So for the monochromator, okay, this gives you the wavelength that is required for the measurement. Okay, so this is very important for spectral isolation. For it isolates a specific or individual wavelength of light, then again, that is needed for measurement. So this also have the capacity to isolate the stray light. Okay, so for example, you don't have the entrance slit because some spectrophotometer don't have the entrance slit. Okay, so there are straight light that could hit the monochromator. So another purpose of the monochromator is that it has the capacity or it have the capacity to isolate the stray light. So what are the different kinds of monochromator? You could either use a prism, diffraction gratings, or filter. Okay, so just to give you an idea or just to refresh you, when you say prism monochromator, it has a wedge shape, or this is a wedge shaped pieces of glass, quartz, or sodium chloride. Diffraction gratings is the most commonly used monochromator for your spectrophotometer, and these are made up of grooves, okay, on a polished surface. And then lastly are your filters. And filters are considered as the simplest, least expensive, however, not precise but useful. Okay, so for filters, it produces monochromatic light based on the principle of constructive interference of waves. Okay? So, depende kung anong ginagamit na monochromator ng ating mga spectrophotometer. But of all of those three kinds of monochromator, the most commonly used is your diffraction gratings. Okay? Next is the exit slit. With the exit slit, this part of the spectrophotometer controls the width of light beam or the so-called bandpass. It allows only a narrow fraction of the spectrum to reach the sample cuvette. Also, this one prevents stray light from hitting the cuvette. So, just in case meron pa ring stray light na makapasok, that stray light, that unwanted, that undesired light should not hit the cuvette. Okay? That's why we have this exit slit. Okay? This exit slit, same with your entrance slit, the monochromator, and exit slit, this also acts on the stray light just in case mayroon. Pero supposedly, dapat wala ng stray light from the entrance slit. Okay? From the entrance slit. Next part of your spectro is the cuvette. Okay? So, the picture shown to you on my slide is actually the cuvette we have here, okay, in our laboratory. So, what is the purpose of the cuvette? Your cuvette holds the solution to be analyzed, okay, or to be measured. So, dyan mo ilalagay yung solution mo, the reagent, together with your sample. when you are to measure that in determining its concentration. Okay? So your cuvette can be round, square, or rectangular. So depende kasi each or kung anong gagamitin mong spectrophotometer, dun magde-depend kung anong cuvette. Dun sa pinakita ko sa inyo kanina na type ng spectro na meron din tayo sa lab, instead of using this type of cuvette na nakikita nyong picture sa slide, we make use of your test tube, okay, as our cuvette. So, depende nga yun sa spectrophotometer na gagamitin mo. So, your cuvette is also called as the absorption cell, analytical cell, or sample cell. But syempre, mas madaling alalahanin yung cuvette. Okay? And its purpose then again is to hold the solution to be analyzed or to be measured. So we have also different kinds of cuvette. We have either cuvettes that are made of alumina or silica glass, and that is very useful when the wavelength use is under the UV region or it's more than or equals to 220 nanometer. Okay? Borosilicate glass is very useful for visible region, and you are to measure, okay, a solution that uses a strong alkaline reagent or for those strong alkaline solution. Cuvettes made of quartz or plastic is mainly used under the UV region if we're going to use wavelength under the UV region. Soft glass cuvettes are used for strong acidic solution, whereas the polycarbonate plastic is mostly used under the UV and visible region. So whenever you make use of UV and visible region as the source of your wavelength, okay, so depende, you can use those kind of cuvette. Okay? So kindly take note that there should be no scratches on the surface of our cuvettes because that can result, okay, to scattering of light, and that should be discarded. So whenever we see scratches in our cuvettes, hindi na natin siya pwedeng gamitin because that could affect the result of the measurement. So you have to discard that. Okay, but in real setting, here in our laboratory, hindi natin siya dinidiscard. Okay? So, pwede niyong gawin yon depending on the SOP of the hospital. Pero dito sa atin, pag pinagamit ko kayo ng cuvette at nakita nyo meron siyang scratches or meron dumi na hindi natatanggal, sasabihin mo, ma'am, tapon ko na to kasi meron na siyang scratch. No, you can't. Okay? Kasi medyo mahal yan. So, hindi pa natin kayang mag-produce na per test, kailangan panibagong cuvette and at the same time per group, iba-iba kayo. No. Okay? So, just in case you'll be using a strong alkaline solution, you should not prolong that in putting those sa ating cuvette because that can dissolves glass, okay? Especially if the cuvette that you're going to use is made up of glass because that can produce etching. So you cannot prolong standing a solution that is highly alkaline, okay, on the cuvettes that are made of glass. Okay. Next part of our spectro is our photodetector. So this photodetector detects and converts transmitted light into photoelectric energy. Okay, so this detects the amount of light that passes through the sample in the cuvette. So kindly take note of this so-called transmitted light. So we have also different kinds of detector. So photodetector could be barrier layer cell, or this is also known as the photocell or the photovoltaic cell. And this is actually believed to be as the simplest, okay, detector. Least expensive, however, is temperature sensitive. That's why it's not really specific. Okay, again, barrier layer cell as your photodetector is known or is considered as the simplest detector. Okay, least expensive, however, is temperature sensitive, therefore not specific. Okay, another kind of photodetector that we could use for our spectro is your phototube or the photoemissive tube. We also have available photomultiplier tube. So this photomultiplier tube is the most common type of photodetector that we use with our spectrophotometer. So it has excellent sensitivity and a rapid response, okay, with the transmitted light. And lastly is the photodiode. And photodiode is a type of photodetector that produces an excellent linearity. Okay, so same with other component or other part of spectro, the most commonly used type, kindly take note, is your photomultiplier tube. However, the simplest is considered as the barrier layer cell. Okay, so next is the meter or the readout device as the next part. So for some, this is the last part or the last component of a spectro, but others nga, they considered having recorder, okay, as another component or another part of our spectrophotometer. So the meter or readout device is known as the galvanometer or ammeter, and this displays output of the detection system. Ayan. Okay, so ayun na nga, no, naputol ako dahil nawalan tayo ng internet. Okay? However, let's go back to our discussion. Okay? So, again, dito tayo nag-stop with the last part or the last component of our spectrophotometer, which is actually the meter or the readout device. Okay? So, your spectrophotometry, okay, this method could either be a single beam or a double beam spectrophotometry. So what is the difference between a single beam and a double beam? With a single beam, this measures the light that passes through or the transmitted light. Whereas for the double beam, okay, so with the double beam, it's that before the light reaches the sample, the light coming from the light source splits into two separate beam. Kaya siya tinawag na double beam. Single beam kasi, isang light source, isa lang yung light na hihit with the sample, and para ma-measure mo din the standard or the reference material or the reference solution, dapat hiwalay sila. Unlike with the double beam, you can simultaneously read, okay, the reference material or the reference solution with the sample. Kasi nga, the light, before it reaches the sample, it splits into two separate beam. One passes through the sample and then the other passing through the reference solution. Reference solution is also known as the control solution. Okay? If not control solution, is standard solution. Kasi si single beam, to measure the intensity of the incident light that passes the sample, okay, the sample must be removed so that the reference can be placed each time. The advantage of a single beam is that it is less expensive and at the same time less complicated. Unlike for the double beam, the advantage of that is that reference reading and sample reading, or that is the advantage naman of the double beam. The reference reading or the control solution reading, the standard solution reading, and sample reading can take place at the same time. Okay? And your double beam class can be done in two different methods, either double beam in space or double beam in time. So later I'll show you a picture to differentiate what is this double beam in space and double beam in time. So again, okay, para mas madali nyong maintindihan, basta single beam, one light source, one light hitting the sample. Okay? So, tanggalin si sample, ilagay si reference solution, control or standard solution, and then measure that. Unlike with the double beam, one light source, Okay? But that light splits into two. One beam, okay, passes through the sample, and the other passes through the control solution or the reference material. Okay? So, ito yung single beam. Okay? So, the usual, okay, spectrophotometer, having those components of your spectrophotometer. Whereas this one naman is your double beam. Okay? So, you have the double beam in space, okay, and the double beam in time. So kindly take note of the difference between the double beam in space and the double beam in time. With the double beam in space, you have one light source with two entrance slit, two monochromators, two exit slits, and two photodetectors. Again, with the double beam in space, one light source, two monochromator, two photodetector. Okay? How about in double beam in time? In double beam in time, okay, you only have one light source also, but with only one monochromator, and this is the monochromator for the double beam in time. However, the monochromator, okay, the light coming from the monochromator by using a chopper, okay, or a light splitter rather, that splits the light wherein one light or one beam passing through the sample and then the other beam passing through the reference, the control, or the standard solution. And at the same time, to differentiate that with the double beam in space, your double beam in time also has one photodetector. Okay? So, nag-i-split lang yung light nila. With the single beam, okay, lahat isa. So, dapat tanggalin muna si sample and then read the reference material or the reference solution. Whereas pag double beam, ang tatandaan nyo lang, the light, okay, splits into two. But when it comes to double beam in space, you also need two monochromator to split the light and two photodetectors. However, in case of double beam in time, you only need one monochromator, but you need a chopper, okay, or a light splitter that splits the lights with interval so that it can pass through then again, splitting the light into two beam, the other beam passing through the sample and then the other passing through the control solution or the reference material, okay, or the reference solution or the standard solution. And we also need only one photodetector. Unlike the double beam in space, you'll be needing two photodetectors. Okay, so I hope you get that, okay, clearly. So just in case then again you have questions, you can ask me, okay, by next week. Okay, so take a note nyo lang yon. And I'm pretty sure this was thoroughly and clearly discussed with you by Ma'am Hawla. Okay, so ni-refresh ko lang ulit kayo. So another important thing when it comes to your spectrophotometer is not only the Planck's formula, but also the so-called Beer's law or the Beer-Lambert's law. So this Beer-Lambert's law is also known as the law of colorimetry. Okay, and this law states that the concentration of a substance is directly proportional to its absorbance and inversely proportional to the logarithm of transmitted light. Okay, so yung transmitted light, ito yung light that can pass through a sample, okay, and that is the one being measured by the photodetector. Yung tinatawag mo naman na absorbed light, yung present na substances doon sa ating solution, it has the capability to absorb the light, okay? And that is what we call as the absorbance. Okay, the absorbance. So in short, this Beer's law or the Beer-Lambert's law only states that there is an indirect relationship between the concentration and the absorbance. Okay? Ayan. The relationship between concentration and absorbance. So speaking of absorbance, as I mentioned, this is the amount of light absorbed by the solution. And absorbance is equals to small letter A, B, and C, where big A or capital A stands for absorbance. Small letter A stands for molar absorptivity or the absorptivity of the compound under standard conditions. B is length of light through the solution, or this is simply known as the light path. And the C is the concentration of absorbing molecules or solution. Okay? So absorbance can also be computed by using this formula. 2 minus the logarithm of percent transmission, okay? Or absorbance is equals to the logarithm of 100 over percent transmission. Question now is, ma'am, how can we get this percent transmission? Okay, so percent transmission is equals to the transmitted light. So this is not I, but rather letter L over, okay, the intensity of light is striking the sample. Okay, so percent transmission is equals to the transmitted light over the light, okay, or the intensity of light striking the sample times 100. Okay, that's how we get the percent transmission, okay, of a sample. So anong ibig sabihin nun? For example, you have here the cuvette. Okay, and we have here the substances that we are to measure. As I mentioned, these substances are capable of absorbing light. So you have here the light source and the light that hits, okay? The sample is what we call as the LO, okay? Or the intensity of light that strikes the sample. So yung mga nandiditong substance, it can absorb the light. However, there are lights also that passes through the sample. And that light that passes through the sample is what we call as the transmitted light. Okay, that is the transmitted light or the LT. So that is used to come up with the so-called percent transmission. Okay, because that is very important when we are to compute, okay, the absorbance of a solution by following or by using that formula. Okay? Ayan. So with the application of the Beer-Lambert's law, we could say that AC over CC is equals to AU over CU. So what do we mean by A? What do we mean by C? What do we mean by small c? What do we mean by small u? A stands for absorbance. And take note, class, that absorbance is also known as OD or optical density. Okay? Whereas C stands for concentration. Small letter C stands for calibrator. However, most of the time, instead of using a small letter C, we use S, okay? And this stands for standard, okay? The standard solution. And the U is the unknown. So, ito lagi yung hinahanap natin. Most of the time, ang hinahanap natin is the concentration of the unknown. That's why sa lahat ng formula na dapat nyong tandaan, okay, when it comes to chemistry and we are now dealing with analyte measurement, you have to take note of this formula. Okay, wherein unknown solution or the concentration of the unknown is equals to the absorbance, okay, or also known as OD of the unknown, okay, all over OD of the standard or the calibrator times the concentration of the standard. So since that is a calibrator or that is a standard, it already have, okay, a concentration that is set by the manufacturer. Okay, so depending on the method, depending on the manufacturer, is the concentration of the standard or the calibrator. Basta hindi na kayo yung hahanap niyan. Whenever we proceed with analyte measurement, that is always given. Okay? Madalas, in real setting, kung may face-to-face tayo, hopefully magkaroon na, you are only to measure the absorbance or the OD of the unknown. Okay? And then for the OD or the absorbance of the standard or the calibrator, merong group na gagawa niyan. So, salitan kayo, depende sa ating mga analytes na i-measure. Okay? So, kindly take note of this formula because you're going to use that whenever we proceed, okay, with the analyte measurement kasi you have to compute, or the question there is always what is the concentration of the unknown. So, for example, for glucose, I'll give you the OD of the unknown kasi iyon yung measure ko sa spectro. So, you have to compute for the concentration. By the way, that absorbance or OD is what is being, okay, seen on your spectro. So, iyan yung binibigay sa atin ng spectro. The absorbance and the OD of the unknown or the standard or the calibrator. Okay? So, again, kindly take note of that formula. Okay? Also, kindly take note that absorbance is also known as OD or optical density. Okay? Ayan. Let's now proceed on how are we going to use the spectro on our laboratory, because this one is very important. This is what you need, okay? So dapat dyan kayo familiar kasi you might encounter this when you become an intern or you become a medtech in some laboratories, okay? Sooner or later. So how to use the spectro on our lab? So we have here the two types of spectro available in the lab. As I mentioned, yung isa nga dyan is Sirana. Okay, parang kapanahunan ko pa yata yan or kapanahunan pa ni Sir Adarbe itong spectro na ito. Okay, so this is spectro is what we have before. Okay, as you can see here, these are the cuvette ports. So we could place our cuvettes there, especially when the reaction needs to take place at 37 degrees Celsius kasi temperature controlled siya. So this is where we insert our cuvette whenever it's ready for reading. Okay, this is considered as the readout device. Okay. And dito tayo pumipindot for the different functions, okay, or setting of the wavelength, etc. Okay? So ito, meron diyang parang lumalabas na papel na ipiprint niya yung result, yung absorbance or yung OD ng solution mo or nung sample mo. Okay? But then again nga, sira na yan. That's why what we are using now in our lab is this one. Okay? This one. So this is called as the C40 implant nanophotometer. So I'm pretty sure you're familiar with this one kasi you deal with spectrophotometer also or with a nanophotometer during your mol bio. Okay? So, ayan. Okay? So this is called as the C40 implant nanophotometer. So these are the different pictures that will show you kung ano bang itsura nitong spectro na to na meron tayo sa lab. So you have there yung tatak, you have the implant and a USB port wherein pwede kang mag-insert ng USB dyan to save the files, okay? That is present on our spectro. Okay? So it has different feature. You have the 7 inches color touchscreen. Ayan, ito yon, the 7 inches color touchscreen para siyang iPad or tablet. You have here the off switch. So pag tapos ka ng mag-read, you have to turn off the machine or the instrument. So you have just to click on that or tap on that. You have here the temperature controlled cuvette holder, or we call that also as the cuvette port. Okay? Cuvette port or cuvette holder. You have here, okay, the power indicator. So pagka ito umilaw, ibig sabihin bukas na siya. Okay? And again, this is what we call as the USB port. Though not limited to that, okay, at the real panel, okay, we have this different feature. So you have the power supply. So kailangan i-insert mo dyan at isaksak mo para mag-charge siya. So you can use that pag full charge na siya or during charging. You have also the USB-B, the HDMI, the USB-A, the Ethernet, and the power on and off. Okay? So you can press that or you can press the off switch icon doon sa ating color touchscreen, either of the two. But most of the time, we make use of the off switch on the color touchscreen rather than the power on, power off at the rear panel. Okay? Ayan. So this Spectro comes with a pre-program application, okay, as well as the ability to create custom application. So to select a method, you just have to click or tap on the corresponding icon present on the touch screen. So as you can see, these are the different icons, okay, that you can observe on our touch screen using that spectrophotometer. And the method will open immediately as you click or tap on that. So on the color touch screen, those are the different icons that you can see or you can observe. So you have the nucleic acids, protein UV, protein assays, kinetics, OD600, stored results, stored methods, and more apps. In the more apps, pag pinindot mo siya or kinlik mo siya, you'll see there the wavelength, okay, concentration, absorbance over ratio, standard curve, custom apps, etc. Okay? So those are the different, okay, programs that we can use, okay, by using this spectro. So if you tap or click on the nucleic acid, of course, you'll be using that if you want to measure the nucleic acid, okay? If you have protein as your sample, you have to press the protein UV. So depende kung anong itetest mo, anong method ang gagawin mo, okay? Anong sample mo, okay? But in our case, okay, for analyte measurement in CC1 and even in CC2, okay, we mostly use, okay, during our measurement, the OD600 method and the kinetics method. Okay, so malalaman nyo when we go through on what is the difference of this kinetic and OD. Okay, but just to give you an idea, pag sinabi mong kinetic, you are to read the absorbance, okay, of a solution more than once. Pag OD 600, pag OD or endpoint, okay, pag endpoint assay naman ang sinabi mo, you are going to read the absorbance of the solution just once. Okay, just once. So kindly take note of the difference just to give you an idea. So that is the two, okay, method that we commonly use during our measurement in the laboratory. Okay? So during measurement, we have also additional buttons that you can observe. So for example, okay, pinrest natin yung OD600. Okay? So again, this is the actual picture, okay, of our spectro, the pre-programmed applications. So forgive me for the very malabo, okay, na picture. But the same lang yan nung sa una kong pinakita, ayan. Okay, sa nucleic acids, protein UV, etc. So by the way, we have also other features here. So you have the battery status, the assistance if you need any help on how to use this, how to use that. Wi-Fi status because you can connect the Spectro to your Wi-Fi. Okay, the off switch that I've also mentioned earlier. Preferences, but others, tulad ng makikita nyo sa picture na to, okay, sa susunod na picture, yung malabo, there is presence of the time and the date. Okay, the time and the date. So again, for example, we press or we click or we tap on the OD600 because that is the method that we're going to use. Okay? So pag kinlik mo siya or tinap mo siya, ito na yung lalabas sa screen mo. Okay? So you have there the sample button, the blank button, the entering the sample name. You have also here yung parang bahay. Nababalik ka sa home mo doon sa ating first, okay, screen. You have here yung parang save icon. Okay? This is the method. I-delete mo ba? And of course, if you have any assistance or any questions. Okay? So, ito naman yung nandito are the different parameters that you can set. Okay? With this method, depending on the method. Sabi ko nga doon sa video, depending on the method are the parameters and at the same time, sometimes they have their default settings. Okay? So, yung sasabihin ko ngayon, same lang nung doon sa video kasi nga ako rin yung gumawa niyon. Iba nga lang yung boses. Okay? So, ayun. Going back with this blank sample and enter sample name button. Okay, so the blank button, kindly take note that this will be pressed, okay, if you are to measure the absorbance of your blank. Okay, so most of the time we make use of distilled water, okay, as our blank solution. And the main purpose of the blank solution is to read out any absorbance, okay, caused by the reagent or the sample. So that is the main purpose of the blank solution. So kung hindi distilled water ang ginagamit natin, we make use of a reagent blank, okay, or serum blank. Depende sa method na gagawin mo. But mostly, we make use of a blank solution. Okay, or distilled pala. Distilled as our blank solution. Okay? So again, ipipress nyo lang tong button na to. Okay? Touch screen siya. So ipipress mo lang yan if you are to read the blank. So the sample button is the same as the blank. Ipipress mo din siya if you are now to measure, okay, the absorbance or the OD of your sample. How about the enter sample name? The enter sample name is pipindutin mo because this is needed for proper labeling and identification of the sample to be measured. So most of the time, kung tayo'y nagkaroon ng face-to-face at nagamit nyo yan, ang ipapalabel ko sa inyo dito is either your group number, so kunwari group 1 yan, or if you want, the last name of the patient. Okay? Kunwari sa group 1, meron kayong naging patient doon, siya yung kinuhanan nyo ng blood that will be used as the sample, okay, for measurement of the different analytes. So, pwedeng iyon yung gamitin mo as your label or as the ID. At iyon yung i-enter mo dito sa button na to or dito sa enter sample name na yan. Okay, so depende. But most of the time, group na lang yung pinapalagay ko. So, group 1 or 1, 2, 3, 4, 5. Okay? So you'll observe here also that we have here the wavelength. So you can press on this, okay, to set the wavelength depending on the wavelength needed to perform the method or the test. Hit to 37. So pagka lang ginalaw mo yan, magko-color orange siya. So that means inon mo na. So pag green na yon, pag green na yung orange na yan, it means that the temperature of the spectro is at 37. Actually, it's not the whole spectro but only the cuvette port that is at 37 degrees Celsius. Okay? Because there are some tests that requires for the reaction to happen, kailangan nasa 37 degrees Celsius sila. Okay? Or at body temp. So you can observe here also the wavelength that you set. So depende yan, pwedeng mag-iba yan. Depende nga sa isiset mong wavelength needed for the test. Okay? So these are the cuvettes available, or this is the actual cuvette, okay, that we use for our spectro. So kindly take note of this arrow head present on our cuvette, because this is very important when we are measuring or when we are reading our sample. Okay, and this is the actual photo of the cuvette port, or the so-called temperature controlled cuvette holder, that has also arrows present on that. So those arrows present on that indicates, okay, the light path of the spectro. So pag ganyan, yung tama ng light, that's why it's very important. Ma'am, para saan po yung arrow na present sa cuvette? Pag in-insert mo si cuvette dito sa cuvette port, kailangan arrow to arrow sila. Okay? Either nakatapat dito sa taas na arrow, yung arrow ni cuvette mo, or nakatapat dito. Wag lang na yung arrowhead present on the cuvette dito nakatapat sa kaliwa or sa kanan. Okay? Because the light will not pass through that way. So there could be, okay, an effect on the result of your sample. Okay? Hindi po pwedeng ganun kasi the importance of the spectro is the light path. Okay? Kaya dapat susundin mo siya. That's why always remember that when you insert the cuvette on our cuvette port using our spectro, kailangan arrow to arrow sila. Okay? Arrow to arrow. Naintindihan. So sana malinaw, sana clear. Ayan. So the step-by-step procedure, first is to select the method you are to use depending on your sample and test method, and set the parameter for measurement. So kindly watch the video. So wala itong sound, so idadub ko na lang ulit siya. Okay? So ayan. So for example, again, I'm going to use the OD600. So iyan ang lalabas sa screen nyo na diniscuss ko naman na kanina, no? Okay? So you have there those different parameters on the screen when you press the OD600. Ayan. So we are now to set the parameters. So by pressing the wavelength, we can put there the wavelength needed for the test. So depende 340, 510, 500, depending on the test and depending on the analyte. So again, if you tap on that, hit to 37, okay, magko-color orange siya. Pag green na siya, that indicates that the temperature of the cuvette port or the cuvette holder, okay, is already at 37. Okay? So, though not limited to those parameters, meron pang iba such as yung ating path length. Okay? So, nag-stop siya, no? Ulit. Play ko ulit yung video class, ha? Ayan. Ayan. Setting the parameters, the wavelength needed depending on the test. So 340 yung nilagay ko for that specific example. Okay? And then by tapping on that hit to 37, nag-color orange na siya. So pag nag-green na yan, sabi ko nga sa inyo, it indicates that the temp is at 37. Okay? So I'm not sure why nag-i-stop. However, iyon lang naman yun. So later naman may video pa tayong iba. At the same time, napakita rin yan doon sa ating video na in-upload sa Moodle. Okay? Wait lang natin. So when you select the OD method, again, this will be shown on the screen. So ayan na yung na-discuss ko kanina. So again, you have the blank button, the sample button. enter the sample name and the different parameters. So we have there the path length, the manual dilution if ever you perform or you want to perform a dilution, smoothing, correction. We have here also a graph, okay, that will show you the absorbance with the wavelength use. So makikita nyo dyan pagka nag-read na kayo. Okay? Ayan. When you already set the parameter, the next thing to do is to read the absorbance of the blank. So bago ka mag-read ng sample, kailangan mo munang mag-read ng blank. So distilled water is commonly used. Okay, but sometimes we could also use a standard solution or a reagent blank as our blank. So then again, that will depend on the method, on the sample, okay? Or kung ano yung sabi na gamitin mo as blank. But sometimes nga, the most commonly used blank is your distilled water. So add the distilled water or the blank solution kung anong gagamitin yung blank to a cuvette and ensure that the filling volume is sufficient to allow light path to pass through the solution. So hindi pwedeng sobrang konti ang ilalagay mo on your cuvette, hindi rin naman sobrang punong-puno. So dapat the filling volume is sufficient, okay, to allow light path to pass through the solution. Kasi nga, ayun ang pinaka-importante dyan, yung light na maa-absorb and yung light na matatransmit ng solution mo. Because that is the main purpose of why we use your spectro. So insert the cuvette into the cell holder or the cuvette port. Once you already insert that, again, take note, that should be inserted arrow to arrow. So your cuvette port has two white arrows. The cuvette has an arrowhead. Sa taas, dapat magkatapat sila. Okay? Hindi pwedeng nakatapat sa gilid. Dapat magkatapat, arrow to arrow. And then, initiate a blank measurement with the blank button. So, pag nalagay mo na yung cuvette mo on the cuvette port, you just have to press the blank button at magre-read na yan. So, may tunog siya. Okay? So, mas ma-appreciate nyo yun if we are in our laboratory. However, I'm really sorry, pero sabi nga natin, hopefully by next sem. Okay? So, upon completion of measurement, you have now to remove the cuvette. Okay? So, upon completion of measurement, ito yung lalabas sa inyong spectro screen, dun sa ating spectro screen. So, we have here blank 1 and blank 2. So, kindly discard the blank 2. Na-press ko lang ulit kasi yung blank button. Pero, sa totoong buhay, isang beses lang tayo dapat nagre-read ng blank. Okay? So, in this case, this is our name. This is blank 1, though hindi ako nag-enter ng sample name for the blank kasi nga isang blank lang naman ang gagamitin natin. Unlike for the sample, so for example, with your case, kung 10 group kayo, 10 yung magre-read, so we have to enter the sample name para may idea kayo. Nasaan yung OD ko dito? Nasaan yung sa amin? Ganyan. Okay? So you have here the wavelength use. So sabi ko nga, we set that at 340. Okay, nanometer. And this is the OD or the absorbance reading of our blank. So dapat 0, 0, 0 ang blank mo. Kasi nga your blank has the purpose to read out any absorbance caused by the reagent or the sample. Okay, that's why you need to read a blank before proceeding with reading the absorbance of your sample. Okay, so next is to measure the sample. So in our laboratory, we mix the sample with the reagent on a test tube. So it's not directly that you mix the reagent and the sample using the cuvette. So, pag sa CC2, kung may face-to-face na tayo, kukuha kayo ng gamit sa counter. Ang usually ibibigay sa inyong gamit are test tubes, okay? Pipette tips, okay? The standard solution, if you are the group, okay, nagagawa ng ating standard measurement, okay? and many more depending on the test or kung ano-ano yung i-measure natin for that day. So using a test tube, dun ka maglalagay ng reagent and then you have to add there the sample. You have to mix that, okay, homogeneously by doing lateral tap, okay? Or basta kailangan ma-mix nyo. Kasi if you don't mix, there's no reaction that will happen. Kaya every time you add the sample to the reagent, you have to properly mix the two. Okay? So after homogeneous mixing on the test tube, so that there should be a reaction, add now the solution to the cuvette. Kasi nga, the main purpose of the cuvette is to hold the solution that should be measured. Okay? Or the solution wherein the concentration is to be measured. Okay? So after doing so, enter first the sample name in the input window, enter sample name. So kung group 1 ka, lagay mo doon 1. Kung group 2 ka, lagay mo 2. Kung group 3 ka, lagay mo 3, so on and so forth. After entering the sample name, because that is very important for proper labeling and identification, para hindi kayo malito when you take and record the result of the absorbance for your sample. So you have to carefully and properly do that. Okay? And then initiate sample measurement by pressing the sample button. So pag sample na yung gagamitin mo or yung i-measure mo, you cannot press anymore the blank button but rather the sample button. Kasi pag pinress mo yung blank, okay? Yung solution mo na nilagyan mo ng sample, that will be now the basis of all the reading, which is not correct because that could result to erroneous results. Okay? Or that could affect the result of other sample. So, kunwari napindot mo yung blank, hindi yun tama. So, we have to make another blank measurement before you can proceed with the sample measurement. Okay? So, pag blank, pindutin ang blank button. Pag sample na, nilagyan mo na ng serum ng classmate, ng pasyente mo, sample button. Okay? But before pressing the sample button, you have first to enter the sample name. Okay? So, upon completion of measurement, remove the cuvette. Transfer the solution on the test tube that you first use, okay, during mixing. And then, let the next group use the same cuvette that you use. Okay, so hindi pwedeng iba-iba. Though, there are times na nagpapagamit ako ng dalawang cuvette, okay, for the whole class para madali. Okay, para simultaneous kayong nagre-read. But kung hindi naman kailangan, we should only use one cuvette. Okay? But the ideal is that one cuvette per patient. So for group 1, dapat isang cuvette kayo. For group 2, another cuvette. For group 3, another. Medyo hindi nga lang practical kasi nga, okay, medyo mahal yung ating mga cuvettes. That's why in our case, what will you expect by next sem is that you're going to use the same cuvette. Okay, only one cuvette for the whole section. For one test, okay, so gagamit naman tayo ng ibang cuvette for other tests, okay, depende. Okay, so sana malinaw. So pag tinanong ko kayo kung naintindihan ba, hopefully, sumagot kayo dyan pag pinakinggan nyo na itong aking recording. Okay? So if not, again, you can take note of what is not clear to you para masagot natin or mapaliwanag natin by next week. Okay? And then check the absorbance reading of your sample and then record. And then absorbance again is the same as OT. Okay? So later I'll show you kung ano bang magiging itsura nung absorbance reading ng sample mo. However, that is already shown to you with the video presented or uploaded sa ating Moodle. Okay? Measure other samples by just repeating the procedure. So when all samples are already measured, it will be shown on the screen. Okay? The result for all. So kung 10 group kayo na nag-read, nandoon yun sa ating screen, hindi siya nabubura, nag-i-stay siya doon. Okay? So when all of you are done reading the absorbance of your sample, you now have the choice to save the file as PDF or Excel or using USB, or you can auto-save that to prevent data loss, or you can just leave without saving. So in our case, since ako yung nagpapatay ng spectro, hindi ko na siya sinesave. But in real setting sa mga private lab or sa mga hospital, it's very important that you save the data or you save the absorbance you made for that day. Kasi that will serve as your reference or basis kung tama ba yung nilagay mo, tama ba yung ginamit mo for the computation para mag-produce ka ng ganitong result. Okay? So again, after using the spectro, you only have the absorbance reading. Okay? Or the OD. OD of what? OD or the absorbance of the unknown and the OD or the absorbance of the standard. Okay? You also have the concentration of the standard kasi nga the concentration was already predetermined by the manufacturer. That's why our question as always when we are to measure, okay, an analyte is the concentration of the unknown. Okay? And we should follow this formula in computation. Okay? So, most of the time, our OD or absorbance, ang lalabas lagi dyan is either 0.052, 0.252. Okay? So, depende sa dami ng analyte na gusto mong i-measure sa sample mo. Siyempre, the higher the analyte present, the higher the OD or the absorbance, okay, that the spectro will yield. So you have to take note of that. So iyan yung i-expect nyo na OD natin. And this is not yet the result. This is not yet the concentration of the unknown na lagi nating tinatanong when we are measuring a certain analyte. So kailangan gamitin mo tong formula na to come up with the concentration of the unknown for reporting. Okay, for reporting. So basta sa ngayon, ang tandaan nyo lang muna is the formula. When we proceed with analyte measurement, so by next week, when we are to measure your glucose, okay, doon makikita nyo kung para saan ba yung formula na yan. Bakit paulit-ulit naman tong si Ma'am Kat na alalahanin yung formula? Eh ganito, eh ganyan. So, re-realize nyo yan when we go or when we come with the analyte measurement in the laboratory. Okay, in the lab. Ayan. So, these are videos that will show you again on how to properly use our spectro. Pero maganda naman na yung video uploaded sa ating Moodle, no? So, by watching that, you can fully understand and clearly understand somehow, okay, on how to properly use our spectro available here in the laboratory. Okay? So, ayan siya. So, medyo naghahang, no, yung aking mga video. Siguro mahina kasi ang internet ko. So, nag-i-stop siya class, no? Okay? So, anyway, ipapasa ko na lang ito sa ating mga coordinators para makita ninyo and para mas malinawan kayo. Okay? Or maybe I can share my screen with you playing this video. O sige, wait lang. Ayan. Wait lang class ha. Para mas maintindihan nyo siya. Ayan. Ayan. So, wait lang. Let's just wait, okay, for the video to play para maintindihan nyo siya. Ayan. Loading na. Wait lang. So, ayaw niya talaga class. Naghahang, no? Nag-i-stop. So, pasa ko na lang tong video na to sa ating mga coordinators para sila na lang yung magpasa sa inyo. Okay? Para mas maintindihan nyo yung ating spectrophotometer operating or how to operate or how to properly use our spectro. Nag-stop talaga siya eh. Sige, wag na nating ituloy. So, that's the end of our simple discussion or orientation. So, thank you for listening. For you have no choice but to listen and watch this. Okay? So, God bless us all. So, then again, another motivational quote or a quote to end this session. So, keep going. You didn't come this far to just come this far. So, never stop fighting for your dreams. Okay? Aja. So, kung medyo hindi man maganda yung result ng ating prelim exam, no? With other subjects or sa CC, so, just keep fighting. Kaya nyo yan. Okay? So, laban lang. Meron pa namang midterms tsaka finals. Bawi lang kayo. Bawi lang ng bawi. Laban lang ng laban. Okay? So, again, thank you for listening. And I hope na naintindihan nyo yung ating discussion. So, sana clear lahat, no? So, I'll just upload this PowerPoint on our Moodle course, okay? And at the same time with the video recording, okay? So, ayun class. Okay? So, thank you for listening and bye! See you next week, okay?